Good evening, everybody. The real troopers are in the room. This is the last presentation for the evening for B-Sides San Francisco 2024. Woohoo! All right, now we have these handsome gentlemen. We have Mr. Gupta, who is a senior security engineer. And then we have Mr. Paralikar, who is a senior software engineer, both at Snowflake. So what I would encourage you to do, we love participation. If you're not familiar, there's something called Slido, sli.do. You can find it on any QR code outside of the theaters, or you can just sign in by doing BSidesSF.org/Q&A, spelled out. So that's Quebec, November, Alpha. And I'm going to turn it over to these gentlemen. Their topic is about security data. All right, thank you, gentlemen. Take it away.
Thank you. Hi everyone, Rishabh and Hrushikesh here, and we are here to talk to you about how persisting and storing and structuring your security review data can help you deal with and tackle security review challenges or questions that you might face in the future, right? And so both of us work on anti-abuse, and given that we do, we inevitably found ourselves having to answer the question, which systems are affected by abuse threats, right? And on face value, this can be a very daunting question to answer, right? Like now you have to think about all the different systems in your organization, and now you're thinking about all the different kinds of abuse threats that might be applicable to them. I mean, where do you even start, right? But as it turns out, some very smart people chose to structure and store all of our security review data, and then we were able to use that to answer this question. And of course, we use some NLP along the way to help us, because that's what everybody does these days. Before I get into the solution that we built and the tool that came along with it and how that was able to identify abuse-related threats, I want to start with the groundwork and all the things that led to gathering of all the data that we were able to then use when we tried to answer the question about abuse, right? And so I want to start with the security review program and what were the challenges and the choices made when it came to it. So the challenges of scaling a security review, I guess one of the challenges that we had was the security review had to be developer-driven. It had to be scaled so that the developers are able to do the security reviews themselves, right? But that comes with a couple of challenges. One is if the developers are doing the security reviews, the security teams want to know how does a change or a new feature or new architecture change or whatever have you affects the security of a system, right? And that can be a difficult one to answer because security reviews generally tend to be unstructured. That can be a document, like a conference page or something, a design doc. They tend to be informal and they're very rarely stored. So it can be difficult for a security engineer to then go back and look at how does this particular piece of security review that a developer did affects the security of a system, right? And then the other part of that is security review or threat modeling in general can be very non-deterministic. And that means it tends to be more of an art than a science. And that becomes very challenging when you hand that over to developers because it depends on the individual's security knowledge, more or less, for them to be able to do a good job at threat modeling. And then if you want consistent, reproducible results from developers, that problem of non-determinism becomes a big challenge. The other part of that is developers themselves, right? Like they don't want to take on additional burden. They want something that's like fast, low friction, and they don't necessarily want to spend a day or two or a week thinking about security reviews. They want to be able to do this as quickly as possible. And so these are the challenges that we thought about solving, and that led to all the different decisions, right? So first we set out to solve the problem of persistence and storing the data, right? And then so the first security review data that we stored was stored in GitHub. And the choice to store that in GitHub was a very conscious one because we wanted the security review data to live right next to the source code that it was about. And we stayed away from the conference pages and the design docs because those tend to have a very short life. They get misplaced, lost in folders, just tend to get forgotten about, versus something like source code and test cases, they tend to live forever, right? And so we decided to persist the data and structure them in Markdown for the risk assessment, Markdown for our threat modeling data. It was XML for the DFD, or the data flow diagram, and that came from the draw.io shapes. And then one of the goals for the security review in general was to be able to have a repeatable, reproducible process for developers that can output security test cases for them. And to that end, the threats and the mitigations, which are the output from threat modeling, are stored as Gherkin test cases. Right, and we chose these formats because these are easy to for machines to parse. You can put them in code and query them or parse them and do all kinds of different things with them. But also they are somewhat easily readable by human beings when somebody's trying to look at it in GitHub. And that's very useful for somebody who just wanted to quickly take a look and make some kind of determination about it, right? So that then solves our problem of structuring the data and storing it, but there's still a problem of developers spending a lot of time doing security reviews because at that time we had a problem. We were following an approach called stride per element. And stride per element for developers tend to be very time-consuming and inefficient. For anyone here not familiar with stride, it's an acronym for a general class of threats, which is S is for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges, right? And the problem is when you start asking developers to think about going to every node or every element in the data flow diagram and then start thinking about all these different things and then come up with a subset that is actually applicable to the DFD, it again becomes very, very complex for them. And then also it becomes very subjective because it's reliant on an individual developer's experience with security. And so what we wanted to do was to take out the non-determinism from threat modeling to basically make it less of an art and more of a science. And to do that, we discovered this approach called Rapid Threat Modeling Prototyping, or RTMP for short. And what that does is it allows developers, or the only input that it needs from developers is a data flow diagram. And based on that data flow diagram, we can, in exchange, give them about 80% of the threats that might be applicable to a DFD or a feature. And that allows developers to then do their threat modeling in a repeatable, in a reproducible way, and we can get consistent output out of that, right? And so this is an example of what a data flow diagram that a developer submits at Snowflake that might look like. And then you can start applying all kinds of RTMP notations to it. So the first notation that you apply to it is the trust zones, right? So trust zones, and the rules for applying trust zones to all these elements is very simple. Anything that's untrusted or out on the open internet gets a trust score of 0. Any node that is connected to a node that has a trust score of 0 gets a trust score of 1, or any trusted node connected to 0 gets a score of 1. The data sinks are always a 9. And everything in between gets a subjective trust score based on its position and importance. So something that's closer to the data sink gets a higher trust score, whereas something that might be closer to the open internet or an edge connected to it gets a lower trust score, right? And so here is an example of what that trust score assignment might look like. So as you can see, a few different things here. The nodes on the far left has a trust score of 0 because that's a browser coming from the open internet, versus if you look at the databases, they have a trust score of 9 because they are data sinks, and everything in between gets a subjective trust score according to it, right? And so once you have your trust zones, all that needs after that is you start applying your stride rules. And the stride rules, the 5 rules that are applicable here, are also more or less pretty simple, and you can consistently apply them to a threat model that you might have on your hand, which is for elevation of privilege, you're looking at any data flow from a node in a lower trust zone to a node in a higher trust zone. For spoofing and denial of service, you're looking at any node that has a trust score of 0 that is connected to a node that has a trust score of a non-zero trust score. And in that case, the destination node gets a stride or a spoofing threat, an S, and then the connecting edge gets a D, which is a denial of service. And then for tampering, you have when the data flows from a lower trust zone to a higher trust zone, the edge connecting them gets a tampering threat. And then for repudiation, if there is an element or a node that has a spoofing threat, and you have a tampering threat on the edge, then the destination node gets a repudiation threat. And for information disclosure, if the data is flowing from a higher trust zone to a lower trust zone, it gets information disclosure, which makes sense because it's flowing from a higher trust to lower trust. And with that, all of that done, you can very easily produce a threat model, right? So with all of that done, with our threat model figured out, with our DFDs at least figured out, we get our data flow diagrams in kind of a directed graph, right? And so what we have are nodes and edges, and all of them have at least a flow direction connected to them, and all of those nodes and edges also have properties attached to them. And with the use of these properties and the use of these these directions, and we can at least ask them the simple question of what threats are applicable to this flow, right? And expand that to the whole diagram to say what threats are applicable to this feature, given all these nodes and edges. And then the other choice here was to answer that question. We basically persisted this node and edge data in the form of two tables as a graph, which one was nodes and edges, and they get stored with all of their properties and everything else. And then you can use this. This basically became these tables with all the nodes and edges and their properties and all that thing became the basis on which we then went on to build whatever the abuse detection tool and questions that we had to answer. But before I get to that, just to quickly explain, once we have these stored in tables, it is very easy to then apply just simple SQL queries to them to come up with all these stride-related threats, right? So the examples are at the bottom here. So if you're looking at spoofing, for example, then as I explained, you're looking at data flowing from a trust zone 0 to a destination that's non-zero, or 1 in this case. You're also looking at, for tampering, for example, where trust zone is, where the source zone is less than the destination zone. For repudiation, you're looking at if a node has tampering and spoofing, if a particular flow has that. Information disclosure if it's flowing from a higher trust zone to a lower trust zone. And you can boil all of these down to SQL queries with where conditions and with all the conditions attached to them to come up with a threat model for all these individual nodes. And that gives you your threat model, right? And so this is to show that we have basically all of this data, all of this risk-related nodes and edges and gherkins and test cases. We've gathered all this data for years now. And so that's the part that made it easy for us to build what we built, right? And so at long last then, we come to the part where we talk about the question that we started with, which is how do abuse threats affect my system, right? But now with the armed with all those tables with nodes and edges and armed with the directed graphs and all that stuff, it becomes a slightly easier question to answer, right? So for the sake of this conversation, we'll keep the abuse scenarios limited to compute and network abuse. And a quick definition here, a compute abuse is basically running malicious code on any compute node, such as like a virtual warehouse that we have, Snowflake. And then your network abuse is just running any code that can carry out network attacks or facilitate like incoming attacks, such as like a reverse shell of some kind, right? So with that said, what we built was retrofit threat modeling. So we have our nodes, we have our edges, and we then had, the problem was then boiled down to coming up with SQL queries that we can apply to these tables and come up with the threats, right? So for compute abuse, for example, we wanted to do find compute nodes where, so basically select all threat models so far that we have, where nodes that can execute code, right? Where an incoming edge to the above node indicates code execution. So you want to see that something can trigger code execution there. And you want to see if that's basically shared code between people or different organizations and stuff. And then for compute abuse or network abuse, you have select all threat models where a node can execute code, and there is an outgoing edge to the open internet, or there's an incoming edge from the open internet, and both of those will have a trust zone of 0, right? But again, the problem here is then how do you define a node that can execute code or a node that can indicate code execution in SQL? Like SQL doesn't understand plain English, but what does? LLMs, right? So LLMs to the rescue. So we had to then take that problem and boil that down to basically make it so that an LLM can go through all the nodes and edges and everything else and answer that question for us. Like what nodes can execute code, which edges indicate code execution and things like that. And we had to be careful about it, do a lot of massaging with these prompts because LLMs tend to produce like a very verbose output, and then you can't necessarily account for verbose output when you're trying to test for where conditions. And so the answer had to be boiled down to a yes or no, or true or false, your preference. But so this is what the query looked like. So basically, given the name of nodes, answer only in yes or no, and tell me if a node indicates code execution, right? And similarly for nodes or edges that can show like if a code is shared on the marketplace, or for network connections, for example. So that boiling that down to a yes or no turned out to be the key, because then we could actively check in where conditions if it's true or not, all right? So that's more or less how we were able to utilize all that data to build a system that developers can use and come up and look at the abuse threats that might be applicable to their feature, and then try to solve them or build test cases around them. And I'll now hand it over to Hrushikesh here, who will walk you through a developer's perspective on all of this.
Rishabh. Hey everyone, before I start, can I get a show of hands? Like, who's a pure software engineer over here?
Say again?
So can I get a show of hands just to understand who's a pure software engineer over here? Cool, okay. Seems like you might be able to save me if I say bad stuff around all these people. Cool. So, cool. So I'm going to add on to what Rishabh said from a developer's perspective and how all of this process helps me in general, right? So I'm working on a feature, and seems like I have to do a security review now. Seems like there's no way around it. I just might have to get it done. So first of all, I have to revise what the threat modeling process looks like. It's been a while I have done one, and I'm not really sure what all I need to complete. So I go through all of the docs and the training videos, and I have identified my entry points, my assets, my trust zones, and I've created the DFD that we talked about. That was fairly simple, but it involved a lot of work, and I wasn't really sure if I have labeled stuff properly, I've created like the right structure, right? The diagram is one thing, but all the trust zones things seems a little bit complex to me. But still, I'm getting a hang of it, and like, let's proceed, right? So I go ahead, I determine the threats now, right? Stride model. Like what? Repudiation? I haven't really used this word in any conversation forever in my life. I don't know what this means. And every few months, I'm searching what it means every single time, right? And then after a lot of searching for the stride model, gathering a bunch of references, looking at old threat models to understand stuff, here I am. I have generated a few threats, and I'm still not sure if I've done the right thing. But okay, hey, somebody's going to help me with it finally. And then I'm kind of getting done with it. I want to really, hopefully, get this done by the day today so that I can proceed on coding some stuff that I planned on. So now I'm determining the mitigations. I'm really struggling over here. Like some of them are fairly straightforward, so I've got the hang of it. But then for the most of it, I don't really have a clue of how do I even mitigate all these problems, right? So I'm going to need some help on this one as well. And the last part, which generally doesn't get addressed, is the whole process of the threat modeling needs to be iterative. We need to change it along the way when the design changes and get in touch with the security team to get consultations. And it's like an iterative process. But then once the original approval I have gotten is done, I'm sure I'm not going to revisit this because of like other pressures and timelines and deadlines. So, coming back to the whole review process, I'm sure you might have heard some or all of these terms that developers say when you are interacting with them. So it works on my machine. Like, how is it going to be any different when it's going to be in the production environment or any other environment? Do I really need to worry about it? Maybe I don't even surface this to the security engineers. I trust the third-party library. Even though it's been worked on by a single person and the last commit was like 2 years old, it satisfies my functionality, so I'm going to use it. Why do you need to review this? It seems like a very small feature, right? I mean, come on, this a lot of process for me to ship something, right? This is understandable. I don't really understand how to fix this particular security issue, but just because of the lack of familiarity with the domain, I am kind of struggling. Should I address this? Should I surface this? Maybe it tends to get ignored. And the best one, we'll address this later, right? I really intend to address it later, but then again, because of other pressures, timelines, design changes I need to accommodate for, there's always a lack of resources, and PMs ask for more stuff, so I want to finish all of that as well. So maybe this gets overlooked as well. So what are the real reasons behind all of this, right? The first one is lack of security knowledge. It's just developers are not really trained. Even in universities, you're primarily focusing on getting your projects done. Nobody's focusing on how secure the project is, right? Difficulty in thinking about mitigations, right? I mean, you need to be really creative, have to have a knowledge of the space to understand mitigations. And now there is this whole abuse threat scenario you need to worry about. Like, how do I know I need to consider this? And why am I not thinking about this, right? This is primarily because I'm kind of focused on technical threats, which are tackled by the traditional threat modeling processes. Like I'll probably identify a SQL injection, all right? And I don't have a attacker's perspective. We are primarily trained on being like having a defensive approach. That's why we end up identifying SQL injections, buffer overflows, things like those, but then really fail to understand how an attacker might misuse the system. Third one is that because I have to think about this whole new class of threats, there's going to be a lot of time involved in thinking about it, and it's going to be a lot more complex. This will always result in a lot more documentation, which I find overwhelming to get stuff done sometimes, and probably tend to stay away from it now. And then it's a generic lack of awareness. And I'm not even sure if my feature is going to be misused. Should I be even worrying about it? Like, who's going to help me understand cases or point of views where it can be misused? And the last one, which is the concern that we have been trying to address, is that the tools today, the stride model, the traditional threat modeling tools, are not really concerned or don't really address all of these new classes of threats that have emerged, right? So it doesn't help me when I'm doing the threat modeling process. It doesn't prompt me, it doesn't guide me through this. So let's look at how the retrofit threat modeling approach that we came up with helps us identify all of the abuse threats and helps us fix this, right? How do I? All right. So I'm going to look at all of my old threat models to identify which of them might have a abuse risk. So I select the kind of abuse, let's say compute in this case. And in the background, what we are doing is processing all of the property graphs with a combination of directional flow analysis and NLP to generate candidates for abuse. So in this case, we have a threat model which contains a presence of a provider, a consumer who's installing some applications that the provider built, and a compute node. The tool has helped us identify in red the compute node that might be vulnerable for compute abuse. This is like the virtual warehouse in this instance. Also on the right-hand side, the tool has generated a tooltip for us to understand what the threat actually means, and has also provided us a different class of threats there. Since it's like a provider and a consumer scenario, we would at least want to select the crypto miner as a use case that we need to address. You click on show mitigations, which shows us a possible list of mitigations. And in this case, we would ideally want to implement all of them and then create gherkins for them. Once we create the gherkins can actually become test cases to be validated later, which means the graph turns blue for us to indicate that the issue has been resolved. With that, we can prove that using your existing security data, we can identify latent abuse cases, suggest risks, suggest mitigations, and this guy's laughing at me, and resolve the issues. Thank you. With that, we're open up for questions.
What was the most surprising thing you guys? Oh, sorry.
What was the most surprising thing about this project?
Given how daunting it looked in the beginning, just how easy it turned out to be to answer. Like, not to say that this was easy, but it was easier than I thought it would be. And then, it's not to say that the solving or coming up with this was easy, but it was definitely easier given all the data that we had. And then second is, I don't think it's shown here, but we were also able to correct some of the data flow diagrams because one of the theories we came up with was if the node is susceptible to like compute abuse, then it also has to have like an elevation of privilege threat. So if the tool identified something that had compute abuse and it did not have an elevation of privilege, I think we found 3 cases, and 100% of them, the data flow diagram was wrong and had to be corrected for there to be an elevation of privilege there. So that correlation also was very surprising.
I can also add one more point here from, again, a different perspective. No matter how much structure you try to add, there's so many different ways the users of the system will tend to use it. And that's how we ended up having LLMs trying to help us, because there's so many ways different descriptions come up. And that was surprising to find that use case and use it to kind of discover a new class of threats for us.
Have you had to describe the data security model in any particular standards?
I'm not sure what the question is.
In other words, are there like stuff from MITRE or stuff from NIST?
Example, something from MITRE or NIST?
We haven't had to deal with MITRE or NIST, at least in the context of this exercise. Maybe in the future, something might show up, yeah.
Do you use the Greekan scenarios only for the specifications, or do you also use them for ongoing reporting?
Only for this specific use case.
Could you please explain the RTMP acronym used when you describe threat model?
It's a rapid threat modeling prototyping, and that's an approach that, again, can rapidly help you come up with threat models.
Final question. Can you please repeat what STRIDE stood for? And thank you.
STRIDE is, S is spoofing, T is tampering, R is repudiation, I is information disclosure, D is denial of service, and E is elevation of privileges.
Very, very good, gentlemen. Thank you so much. You did an amazing job. You did Snowflake proud. This concludes this presentation. Thank you so much for being troopers. Right next door in 13 is going to be closing ceremonies from 6 to 6:30. I want to thank Marco in the room. He's our AV specialist. He's been my right hand all day taking care of audio and video. So we appreciate him, specifically all of our volunteers. Yes, thank you so much.